Kelvin, and this is my colleague Gan. And today we are going to talk about Spark Uber Development Kit, and internally we call it Spark UTK. So something about our working company, Uber. Our mission is to make transportation as reliable as running water everywhere for everyone. And Ken and I, we are working in the Hadoop team of the data infrastructure organization at Uber. Our team, we build service and infrastructure for data, and we implement the schema system at Uber. We also build our HDFS data lake. We also run the analytic engine for our people. And Gen and I, we are focusing on the Spark computing framework, services, and tooling at Uber. So before we talk about the UDK, let me introduce like a high-level overview of the Spark execution environment at Uber. And it is pretty complex. First of all, we have multiple Spark clusters at Uber, and they have different sizes. Some of them is pretty big, and some of them is smaller. And the size of the largest one is 20 times larger than the smallest one. And also, they use different resource scheduling framework. Some of them we use Yang, and some of them we use Meso for different business or use cases reasons. And for the virtualization technology, some cluster we run Docker on top of Meso, and then some of the cluster we just use the basic JVM. And also for the file format, there's a lot of different variety too. We have a lot of Parquet files, but at the same time, we also have ORC file format, sequence file format, and some of them we just use the basic complex test files. And also, to make the thing even more complex, we have a lot of different technology and service surrounding the Spark environment. We have a lot of home-built services, and at the same time, we use a lot of open source technology like Hive, Kafka, and the Elasticsearch ELK. So, because like the environment is so different, right? We have different cluster, and they have different like configuration, environmental, environment specific. So the impact is for the Spark beginner. We get a lot of feedback saying that, hey, it is pretty difficult for them to, for the beginner to create the first Spark job. Even sometimes for the experienced Spark user, it is not easy too, right? Because like every time they write a job, they need to know the detail, the cluster environment they need to run, right? And also when they try to migrate that single job to another cluster, it is not trivial, it's not straightforward. They also take time for them to like, we do a lot of like different configuration or performance tuning. And this is the reason that we want to build a Spark UDK. There is a few goals we want to achieve in the UDK. The first one is to support multi-platform. We want to abstract out all the environment detail so that like the goal is like the engineers, they just need to implement the code like runtime. And then like transparently, when they need to migrate a job to a different cluster, it is just done, right? They don't need to do a lot of things, just like maybe one line change of in the UDK configuration, and then that's it, right? And then the second goal of the UDK is to make it self-service, right? So the engineers, they don't need to pay me or GAN. They can create and run their Spark job like super easy by the UDK. And then the last thing is like we want to help them to run the job like reliably, right? We want to make the job like reliable and also make sure that they use the best practice and they won't cause any problem to the overall Uber infrastructure. So we can use this diagram to understand the UDK, right? So in the vertical dimension, UDK basically consists of two major features. It is a collection of API, and also it is a collection of tools. So we like to imagine that this is something like the Java SDK, right? Java SDK also has a lot of API and also have a lot of tooling. So UDK is like similar idea. And then in the horizontal dimension, right? UDK has two major target users. The first one is the engineer, right, to help them to create and run Spark job, right? And then the second one is the SRE team. And SRE here stands for the site reliability engineer, right? And they have a different focus compared to the engineers. So for the engineers, like they want it to be easy, self-service, multi-platform. And then for the SRE, they want UDK to help them to make the system reliable, right? And like keep the site running, right? And then like in the talk, we will not have time to go over every feature in the UDK. So we select a few features to like go over the motivation and the principle behind the idea. And in the talk, we are going to put the feature like into these like 4 boxes. So the first feature, which is actually pretty simple, but a very powerful feature for our users, which is we call it like SC Builder, a Spark context builder. So basically, it's an API, and it is a builder pattern for creating Spark context. So the idea is like to abstract out the cluster detail, like the Spark engineer, when they create a job, they just call this API, and then automatically, transparently, they will get back a Spark context, and that Spark context will have all the like configuration optimized for performance, debugging, and also the environment configuration. For example, like where's the host of the YARN, resource manager, the port, right, the history server, all those of things, right? The engineers, they don't need to individually set the configuration one by one. They just call this single API, and then they get a optimized Spark context already, right? And at the same time, we want to enforce some like best practice using this API, right, from the SRE point of view, right? Like through the SC Builder, like the Spark context will come along with a optimized, for example, efficient serialization format. And also, like we'll also help the SRE to configure the optimal like CPU and memory setting. And then the second feature, which is a feature in a bigger area, which is like a lot of users, after their job is done, they want to send the job result to something else, to some other service in the Uber environment, right? So at Uber, we have a bigger, like, even more complex infrastructure, and Spark is one component, right? So this feature is more about like how to integrate efficiently Spark with the environment at Uber. And Kafka is one of the examples. So Kafka is very popular at Uber, so we use it in a lot of places for message transfer. And this API help the Spark job at the end. We can help them to, like, in parallel, send the Spark job result to our Kafka infrastructure internally. And the RDD is the first citizen in this API. It's super easy, just one call, and then it's done. The result will be sent in parallel to the Kafka and then to other services. And we have feature like we build in the HA, high availability feature into this API, so the user, they don't need to do it by themselves. And also we have other like SRE feature, like for example, we do rate limiting. We make sure that the Spark job will not have like too much parallelism and overwhelm the Kafka infrastructure. And then we also try to enforce the message integrity by putting schema on top of the API. And then a second and a third feature in the UDK is actually a tool. And again, it's a very simple idea, but very powerful. So we have a lot of, a bunch of job template, right? So there's some like popular pattern that people, they do it again and again at Uber. And we abstract out the pattern and put it into a collection of template. So they find it like super easy to use. And like for the jobs they need to do in the template, usually like before, they may spend a week to do those things, but like with the template, like they can finish the Spark job within a day. So let's take an example, right? So this is one of the example workflow of people they want to create at Uber, right? And in this workflow, you can see that the environment is pretty complex, right? We have Kafka infrastructure, we have infrastructure for Hive, and then we have our own built-in query UI. We have a Elasticsearch cluster, and then we also have our reporting solution, right? And Spark is one component in the whole environment, right? So before the UDK, people may spend a week, right, to finish this kind of workflow application, right? And most of the time, they are spending on like how to integrate, make sure it works with the whole environment. And then they spend less time on their application and business logic, right? But then like using the UDK feature and the API and the tooling, they can build this kind of complex dashboard application within a day. So, and there's a lot of like example, like people just build this kind of thing like within a day with the UDK. And this is a huge win for the efficiency. And I go over like 3 features in the UDK. Now I'll pass it to my colleague, Gan. He's going to cover like 2 more features.
Thanks, Kevin. Hi, I'm Gan, and now let me introduce Geospatial Processing API in UDK. At Uber, we have tons of trip data and GPS logs, and many data scientists use Spark to do geospatial processing, and most of them are based on SQL queries. So UDK provides a bunch of UDF to facilitate their processing. UDF here means user-defined function. Here we list several examples. The within UDF can help you decide whether a geometry object is inside an area. For example, you can use it to decide whether a car is inside a city. And the contains UDF can help you to find out if the area contains another object. It's a reverse version of within. You can use it to find out all the cars inside one city area. Let's look at other 2 examples. The overlap API can help you to find out whether 2 objects has overlapping area. For example, you can decide whether 2 trips are similar or not. And then the intersect API can help you to find out whether 2 geometry objects have intersections. For example, you can find out all the gas stations along a trip route. You can use this UDF to build very interesting applications. Other than the UDF, there is another common use case at Uber, which is Spatial Join. Spatial Join means that you want to join 2 tables based on geospatial relations. For example, if I want to associate all trips with their city IDs within a single day, then I will write a simple query like this. I select trip ID from trip table and the city ID from city table, and then join them based on the content UDF, which I mentioned in the previous slide. The content UDF means if you find a city shape contain the trip location, then we'll give the city ID to the trip. It looks very simple, right? But it will run in 1 week because of Uber's data scale. The problem is that at Uber, we use Spark 1.5 in production, and it does not have broadcast join optimization for non-equation join. So actually, the physical plan is a Cartesian join. You know, Cartesian join is very inefficient. So actually, there is only 1 executor used at the last stage, which is not scalable. We cannot accept it in our production. So our idea is to build a UDF to broadcast geospatial index to every executor so that we can totally avoid spatial join. It consists of 3 steps. The first one is to build runtime index. The reason why we want to build runtime index is that many tables, like the city table, is always changing because Uber is expanding its business to new cities almost every week. So we cannot build static UDF and use it forever. So now we get those fields from the tables like the city ID and the city shape, and then store them into data structure like chord tree and R tree for fast spatial retrieval. And this step is done at Spark driver side. And then we broadcast the index to executors. We have built-in UDFs in UDK, which use those broadcast index so that in every executor, we can access those index. For example, we have getCityID UDF, which returns the city ID of a location. And the last step is to use the UDF and avoid spatial join. So the final result is 2 minutes. It's quite fast. So many use cases use spatial join at Uber. So Spark UDK helps a lot for their performance. Just now, Kevin has talked about Spark Plus in the UDK tools. And now let me introduce another tool, which is Spark Chamber. When I first tried to write Spark jobs, I was impressed by its powerful features. But when it came to debugging, I lost myself because there are tons of log files across different machines. And when I tried to write a simple program to parse log files, I still failed because the overall file size is so huge that it's out of capability of a single machine. And what's more, if you want to find a specific log, it's like to find a needle in the haystack. And many engineers at Uber are Spark beginners, so it will take them a while to get started with Spark. So we introduced Spark Chamber. It is a distributed log debugger for Spark. It is interactive. We extend the Spark shell by hooks, so it's very easy for Spark developers to adopt. Now let me show a simple debugging session in Spark Chamber. This is the start screen of Spark Chamber. It just looks like a Spark shell. So what you need to do is type in some commands. Now, by default, it automatically loads the most recent application ID of your own. It makes sense, right? Because in most cases, you want to debug your most recent failed job. And it provides some commands like username and application ID to print out the current debugging session. If you don't know which application ID to debug, don't worry. We have built-in commands like all application IDs to print them out, and they are sorted by time. Suppose I have a failed job in mind, and I have no idea about what's wrong with it. So I set its application ID, and then use the host command to print them. So from the result, I can see the mapping between the executor and the host name. So if I am interested in one executor, I can dive into it. Then the most powerful feature is the first exception. In most cases, the root cause of your failed job is the first exception. If it happens in the driver side, it's very easy for you to do because you can view it in the Spark history server web UI. But if it happens in the executor side, it will take you a while to find it out. So using this command, it tells me that it is out of memory error happened in execute 4. So it also prints the host name, execute number, and the stack trace. It's very simple. Now, I enhanced my log and use the search command in the red box to print out all the data count in every partition. Now, from the yellow box, I know in partition 3, it has an abnormal number, then it's far more than other executors. So it's actually a partition problem. So now Spark Chamber helps me debug this problem a lot. OK, other than features I mentioned in the demo, there are other features like you can get all the exceptions, get all the messages. Also, you can display metrics information like CPU usage, memory usage, and disk I/O. You can also dive into a specific driver, executor, and even a machine. Last but not least, you can also search whatever log you want using Spark Chamber. We have also considered of security. So we have 2 modes. For the developer mode, the developers can only debug their own jobs. They cannot view others. For SRE, they can view and monitor all the Spark jobs on the cluster. How Spark Chamber gets those log files? In Yarn, we use a Yarn log aggregation to get all the log files onto HDFS. And in Mesos, it has similar approach. And the log files are separated by username and application IDs. Also, inside one application ID folder, the files are named after their host name, so it's very easy for Spark Chamber to pick them up. How we make Spark Chamber works? The basic idea is to use Spark to debug Spark. We extend Spark shell by hooks, which means that for one application ID, it will distribute all log files to different executors so they can be processed in parallel. And then inside each executor, it will extract all log lines and then save them into data frame. And then we will sort the log data frame by time and by host name, so we can give them a global order. By the global order, we can search them very quickly. And the last step is to use Spark SQL data frame API to retrieve those logs. Now let me pass it back to Kevin for future work.
Thank you again. Cool. So yeah, again, introduce the Spark Chamber, and for the version of the engineers, Spark Chamber right now has about 20 command, 20 features. They can do different things for the engineers to debug their Spark jobs. And then in the future, we would like to build a version for the SRE team, and they will have a different set of features. So we are planning like the SRE people, they are more interested in what is happening in the cluster, right? So they want to have a summary view of, like, for example, I want to know everything about all the jobs running in this cluster, or I want to know the summary or everything about the jobs of a single team, right? So we will have a different command and feature to help the SRE team to do the analytic. They can have different they can dive into different dimension to see what is going on in the cluster. They can also dive into the time dimension, oh, I want to know everything about last month, all the jobs activity last week or even yesterday, right? And then they also want to know something happened in terms of the hardware network topology, oh, give me all the information of the jobs of this specific rack or port. So this is all the thing we want to build. Now we have all the information about jobs, then actually they can do a large-scale understanding how efficient the hardware resource is being used in the cluster, right? They can do different kinds of resource auditing. And also they want to check the data access, what the team is doing with all the data, right? So we have many data, so much data, then we want to do some kind of data access auditing. And also now occasionally we have job failures, right? It is inevitable. Then we have a lot of this kind of failure information too in the logs, right? Then we can do some kind of machine learning to understand the failure pattern in the cluster and do some diagnostic. There's something that we can do? And also try to detect is there any jobs is doing any bad thing? And then one last thing is performance optimization. We want to build feature to look into the log and find out, hey, is there any tuning we can do to optimize the whole cluster performance? So this is all the features we want to build in the future. And today we haven't covered all the features in the UDK. And in the future, hopefully we'll have other chance to share more update with the community. Before we close the section, I just want to share with you guys that we at Uber, we have 2 more sections in the Spark Summit. One session is today at 4:40. Our colleague Dara is going to talk about how we do interactive lookbook application on top of Spark at Uber. And then tomorrow, my colleague Alain and I will talk about a machine learning specific application on top of Spark. So if you are interested in the specific application of Spark, please join us today and tomorrow. Thank you. This is the end of our session.
Excellent. All right. So now we're going to take some brief time for questions. See here.
Thanks for the talk.
Thank you.
Quick question on the Spark plug functionality that you mentioned. You know, this concept of reusable templates. If you can illustrate that a little bit more, how are you enforcing these templates, and how are people able to add new templates to this repository?
Right, right. So, so currently, all the templates are created by our team. So basically, we talk to the Spark user at Uber, and then we collect the feedback from them to understand what are the popular jobs they create frequently, and then we create a template for them to use. So basically, it is like the UDK is a bunch of library, right? So they download the library, and then they, like in one of the folder, there's a template for them, and they can just run the Maven. So we use the Maven build. So they run the Maven with, of course, they need to pre-config something according to their need, right? And then after the Maven, the compilation is done, then the template, the basic idea is there already. And then, of course, there's some business logic they still need to fill in, right? But the idea is that they can focus on the business logic, right? All the other detail, like how to get the Spark context, where's the history server, it is already inside the template. They don't need to spend time on it. Yeah.
Any plans to open source any of these tools?
Right, we would love to. So we get a lot of benefit from the open source community. So when we have time, basically, then we would love to open source some of the tooling. Not every API, because some of the API is Uber specific, but for the feature, which is general enough to the wider community, we would love to open source it in the future.
Any other questions? All right, let's give our speakers one more round of applause. Oh, we have one more. Sorry. Hold off on the round of applause. We have one question.
In the Kafka Dispersal feature you mentioned that there's some kind of a built-in edge trace support. Right. So I'm wondering what kind of edge trace support does it come with?
Right. So basically, we leverage the Kafka broker HA. So in Kafka, you can configure they have multiple broker, right? So basically, what we did is our client will be aware of the different Kafka broker in different regions. And then if one of the broker die, then we automatically fail over to the available one. Yeah.
All right, now let's have that one more last round of applause. Thank you very much.
Thank you, guys.